Hi, I'm David, and today I will be presenting a short talk on the faint sun paradox. The luminosity of the sun was much dimmer 3.5 billion years ago. During its early light, the sun did not warm our planet as much as it does today. This is because the fusion rate in its core was lower, and this resulted in a dimmer star, with just 70% of its present brightness. In fact, radiative output from the sun was so low that all surface water on Earth should have been frozen solid during its early history, but this was not the case. Fossil evidence showed that Earth was most likely a warm water planet as early as 4.4 billion years ago. How could the sun be so dim but the Earth so warm as to be able to possess liquid water? This is the faint sun paradox. In the 1960s, scientists discovered that zircons, which are the oldest known terrestrial object on Earth, showed ratios of different forms of oxygen, which suggests that they may have interacted with water as far back as 4.3 billion years ago. This finding validated the suspicion that the Earth may have possessed liquid water far earlier than what we once thought. Furthermore, in 2015, geoscientist Elizabeth Bell and colleagues at UCLA found carbon from biological sources inside other zircons. They inferred that these sources may be the remains of organisms at or before 4.1 billion years ago. These findings contradicted what we assumed about Earth's early climate history and spurred scientists to propose alternative explanations on how liquid water could have existed. One of the first plausible explanations was suggested by Carl Sagan and George Mullin in 1972 when they put forth the idea of the presence of a thick atmosphere of ammonia which enabled Earth to trap more heat. But this model was soon abandoned upon realizing that ammonia is short-lived in the atmosphere due to UV radiation destroying it. However, the idea of an insulating atmosphere was not lost to scientists, and in the late 1970s an alternative gas was proposed as a possible candidate. The gas suggested was CO2, which is long-lived, on average spending about 114 years in the atmosphere before disintegrating. In the upcoming years, CO2 as an insulating gas would be further explored with many findings that support this idea. Further support for CO2's role in warming early Earth was put forth by noting that volcanic activity could potentially release enough of this gas to overcome the faint sun paradox. However, two issues arose which hindered its mass adoption. The first is that it is impossible to confirm the CO2 levels in the atmosphere from 4 billion years ago due to the lack of actual sample data. Secondly, and perhaps more importantly, was the understanding that crust, basalt, or other silicate material added to soil would slowly dissolve and react with CO2 to form carbonate. This sequestration of CO2 from the atmosphere would have likely prevented the Earth from attaining the levels of CO2 required to trap enough heat. Other explanations were also proposed which were not related to CO2. One theory pointed to volcanic activity which may have darkened the Earth to such a degree as to reduce its albedo significantly. Another is that Earth could have gained heat energy as a result of being bombarded constantly with a barrage of rocks. Finally, some have even suggested that, due to the Moon being closer to the Earth early on, Earth may have experienced extreme tidal heating which would have kept it warm. Which explanation is the most probable is still unknown. However, the consensus is that none of these scenarios on its own would be enough to raise the Earth's temperature high enough and for a long enough period for Earth to have liquid water for most of its history. Therefore, the most likely explanation to the faint sun paradox would likely consist of a combination of these factors. Many of the points covered today come from an article published in the January 2022 edition of Quantum magazine. The article describes a computer simulation model performed by Toby Tyrrell, an Earth scientist at the University of Southampton. In his quest to discover how life could form in the universe, he simulated 100,000 planets, each of which started as habitable, and subjected each to 100 different climate scenarios. His results showed that, for 91% of the planets, not a single simulation kept the planet habitable over its geological timescale. This observation led Tyrrell to conclude in his report that Earth's success was not an inevitable outcome but rather was contingent. As he put it, it could have gone either way. It is in my opinion that the author of that article, Jonathan O'Callaghan, has a profound appreciation for Tyrrell's work. You can read more about this subject by searching for O'Callaghan's article, which is aptly titled, "A Solution to the Faint Sun Paradox Reveals a Narrow Window for Life."